This video is about arcs and arc addition. So our goal is to demonstrate knowledge of an arc addition. So before we can do that, we need to get to some vocab. So remember, a central angle is an angle whose vertex is at the center of the circle. An arc is an unbroken part of the circle. So remember, in a circle here, we have our center point. If we have our central angle, the part of the circle that's intercepting, this is going to be called the arc. Now, the measure of the central angle is always going to be equal to the measure of the arc. So if the central angle is 100 degrees, that means the arc is also going to be 100 degrees. So let's look at some more vocab involving arcs. So there are three types of arcs. There's a minor arc, a major arc, and a semicircle. So a minor arc is an arc that is inside the central angle. It is always going to be less than 180 degrees. When we name a minor arc, we're always going to use two letters. So in this picture of the circle here, there's actually three arcs. There's arc AB, that has two letters. There's arc AC, again, two letters. And there's also arc CB. All of those are less than 180 degrees, so they are all named with two letters. A major arc, then, is an arc that is outside a central angle. It is always going to be greater than 180 degrees. When we name a major arc, we're going to name it by 3 points. So, for example, if AB was our minor arc, our major arc here would go the other way around the circle. Now, with a major arc with the three letters, you have to go in order how you're going around the circle. So we can either go A, C, B, or we can go B, C, A. Both of those are named with three letters, so order doesn't matter as long as you are going around the circle in a circular motion. So you can't go from A to B and then to C. That's breaking up the pattern, and that's a different arc. Then the last one is a semicircle. So a semicircle is going to be half of a circle. It's going to be intercepted by the diameter, so it's always going to be 180 degrees because a circle has 360 degrees. Again, it also has 3 points. So in this case, DF is going to be the diameter, which makes that arc on the top a semicircle. So this arc right here would be a semicircle. We can name it with three letters, so it's DEF or it's FED. Identify the type of arc given that MP is a diameter. So in the first one, we have NQ. It's less than 180 degrees of the circle. It's also only named with two letters, so this is going to be a minor arc. The next arc is PQM, and we have to follow those letters in order. So PQM, remember that PM is a diameter, so this is going to be a semicircle. The next arc then that we have is MQN. So that is bigger than half the circle. It's named with three letters, so this is going to be a major arc. Our next arc, PN, is two letters. It's less than 180 degrees, so this is going to be a minor arc. And our last arc then that we have is PMQ. So we're going to go P to M to Q, which is going to be a major arc. So remember that all circles are always going to have 360 degrees. This is important to help us when we're trying to find different central angles or arcs of a circle. Find the measure of each arc of circle C, given that AD is a diameter. So we know that AD is a diameter. It's splitting that circle into two semicircles. So first one we're looking for is AB. Well, AB is going to be the same as the central angle, so it's going to be 117 degrees. The next one is BD. Well, we know that AD is a diameter, so it's creating 180 degrees of that semicircle, and one arc is already 117, so we can do 180 minus 117 to get us 63 degrees. The last arc that they want us to find is BAD. So BAD, we go from B to A to D. We run around most of the circle, not including that 63 degrees. So we can find it two ways. We can either subtract 360 minus 63, which will get us 297 degrees, or we can add the two arcs because we know that this is 180 degrees, so we could also do 180 plus 117, which will equal the same arc. So there's two ways to get to the same answer. Pause the video now and try number 2 on your own. So in number 2, you should have gotten that arc AB is 72 degrees because it's the same as the central angle. You should have gotten that the arc BD, if it's part of our semicircle, we can subtract that from 180, the 72 that we already know, and we get 108 degrees. And then the last arc BDA, DBA, D and A are points on the diameter, so they create a semicircle. So as we have already kind of used this postulate, we've also seen this with segments, we've seen it with angles, so it's the same kind of idea here of that if two arcs are next to each other and we add them together, they're going to equal the bigger arc. So if AB is 30 degrees and BD is 40 degrees, together that arc would be equal to 70 degrees for AC. So let's use that idea further. So number 5, we need to find arc PR and the measure of arc RTP. So PR, we know that QR is going to be 63 degrees, and part of the arc is already 41, so we can add 41 plus 63. So the measure of arc PR is 41 plus 63, 104 degrees. The other arc that they want you to find is PTR. So remember again that a circle is 360 degrees. PTR does not include anything we used in PR, so we can just do 360 minus 104, and we would get 256 degrees. Pause this and try number 6 on your own. In number 6, you should have been able to add those two central angles together to get that arc YV is 115 degrees. Then the other arc, XUV, you followed around the 23 degrees, so we can do 360 minus 23. Number 5, given circle L, QM is 5x plus 3, MN is 3x minus 9, QN is 58 degrees, and PQN is 23x plus 118. So we can do the two smaller arcs are equal to 58 degrees to solve for x. So 5x plus 3 plus 3x minus 9 is equal to 58 degrees. We get 8x minus 6 equals 58. 8x equals 64. And we add 6 to both sides. Divide by 8, so x equals 8. Then once we found x is 8, it wants us to find all of our arcs, so we can substitute in. 5 times 8 plus 3 is 43. 8 times 3 minus 9 is going to be 15 degrees. And then the last arc, 23 times 8 plus 118 will get us 302 degrees. Number 7, given circle T, we know that DE is 3x plus 15, EL is 5x minus 9, DL is 94. So first thing we want to do is we want to solve for x. So we know that the two smaller arcs, 3x plus 15 plus 5y minus 9 is going to equal 94 degrees. So we get 8x plus 6 equals 94. 8x equals 88. So x is 11. Once we know x is 11, we can substitute in. So we know that DE is going to be 3 times 11 plus 15, which is 48 degrees. EL is 5x minus 11, so 5 times 5x minus 9, so 5 times 11 minus 9 would get us 46 degrees. Then to get LZ, we know that this is a semicircle because DZ is a diameter, so we can do 180 minus the two arcs we already know. So 180 minus 48 minus 46 would get us 86 degrees. Then the next arc that we are looking for is DEO. Well, to get DEO, we need to know OZ, and we can find that easily because these two central angles, DTE and ZTO, are vertical angles, so they're congruent, which makes this arc 48 degrees. So to find DEO, we can just add 48 plus 46 plus 86 plus 48 together. And when we add those together, we get 228 degrees. Next, we want to find angle DTO. So DTO is this angle right here. And we can find that because we can do 360 minus that yellow arc from the last problem that we just did of 228. And when we subtract those, we get 132 degrees. Remember that the arc is the same as the angle, so this angle would be 132 degrees. And then the last angle is LTO, so LTO is these two angles together. So to add those two together, we would get 48 plus 86, and that would be 134 degrees. Number 8, we know that BI is 5x plus 20. We know that IG is 3x plus 24. GL is 2x plus 36. And AL is 7x plus 34. This circle, they didn't give us any numbered measurement of one of the arcs, but we know that BL is a diameter which creates a semicircle, so we can use the three arcs to solve for x. So we have 5x plus 20 plus 3x plus 24 plus 2x plus 36 is equal to 180. So in this case, when we combine our like terms, we have 3x, 2x, and 5x, which will get us 10x, plus we have 20 plus 24 plus 36, which gets us 80, is equal to 180, so we can subtract 80 from both sides. 10x equals 100, divide, x is 10. Now, once we know x is 10, we can start substituting into some of these arcs. So we need to know AL. So AL, we have 7 times 10 plus 34 would get us 104 degrees. The next arc, before we find the next arcs, we're just going to find the rest of the angles. So 5 times 10 plus 20 is 70 degrees. 3 times 10 plus 24 is 54 degrees. And 2 times 10 plus 36 is 56 degrees. Now we can also find BA because again, BL is our diameter. So if I do 180 minus 104, I get 76 degrees. This will help us finding the remaining arcs. So the next arc is AIG. So to find AIG, we can add 76 plus 70 plus 54. And when we add those together, we get 200 degrees. The next arc that it wants us to find is IL. So IL is made up of IG and GL. So we can add those together. 54 plus 56 will get us 110 degrees. The next arc is BLA. So we're going almost all the way around the circle except for that last part of arc BA. The easiest way to find this then would be 360 degrees minus 76. So when we do 360 minus 76, we would get 284 degrees. The next arc, or angle, sorry, the next angle is IJL. So it wants that whole arc, which is the central angle to IL, and we already know that IL is 110 degrees. So this is also going to be 110 degrees. Our next angle is angle AJI, which is incorporating arc AB and BI. So we can add 76 plus 70, which would get us 146. Then our last arc that it's asking us to find is BAL. Well, remember that BL is a diameter, so it's creating a semicircle, which is going to have 180 degrees.